Hi everyone, I'm Sai Avinash. I'm currently working as an SRE SWE at Google Dublin. I'm all India rank 3 at Code Chef. I previously interned at Uber. I'm a master at Code Forces and I'm also a Snackdown finalist. A little about myself. I like playing table tennis and foosball. I enjoyed a lot. And I used to do a lot of computer programming in college, and I currently occasionally give contests on Code Forces and at Coder. The subjects that I take are discrete mathematics, graphs, and dynamic programming, and a lot of other computer programming topics that are frequently occurring. Use the code SciLife to get a 10% off on the Unacademy Plus subscription. So, what do you get with the Plus subscription benefits? What are the benefits? What do you have for it? You get to interact live with India's best programmers. You get live classes like what more do you want? And you get complete doubt support with them. Like if you have any doubt support, if you're stuck at anything, if you're learning a new concept and you're stuck at anything, you can ask them in your live interactive classes. And to add on top of that, you get to practice problems at Code Chef. Like these practice problems will be explained by India's best programmers live, and any doubts that you have will be explained live. So use the code SciLife to get 10% off on the Unacademy Plus subscription. So what are the new batches on Unacademy? There's Transpire, Operating Systems, DBMS, and Networking Master Course. It goes live on 20th July. It's a 1-month durated course. This is Ekalavya 3.0. It's a complete course in Java programming for beginners. It's an 8-month durated course. It goes live on 21st July. There's Brahmastra 3.0. It's an exclusive 5-month learning track for college and off-campus placements. It goes live on 20th July. It's a 5-month durated course. There's Mahayuddha 2.0. It's a 6-week master course on advanced programming topics. It goes live on 20th July. It's a 2-month durated course. To add on top of this is a bug bounty. It's an opportunity for all learners to report any inappropriate content on the video. You're gonna claim a prize if you are the first one to report any particular issue, and it's gonna help the platform grow as well, to help everyone to. Please report any inappropriate content using the form in the description. So, if you think this is going to be helpful to you, do like, share, and subscribe. So, what am I going to take? I'm going to take the course, Maths for Programming. Who's it for? If you're starting computer programming, if you want a place to start computer programming, you know a language, you know a programming language, but you want to start somewhere, this is the absolute right place for you to start. This course is designed for beginners aspiring to get a strong base with math for computer programming. This course is going to build a base for you to understand intermediate to hard concepts in maths. Of course, it won't help you solve problems there, but it must have happened a lot of times that when you're learning a solution, when you're learning a problem, solving a problem, you didn't get the solution, that's fine. And you're looking at the solution, but you don't understand what's going on. That's normal, for hard topics or medium hard topics, it's normal. This course is going to build your base to understand those problems and make you grow by learning more math. Yeah. So the prerequisites for this course are pretty minimal. You just need to know programming language and just high school math, which you probably already know. And that's it, and a will to learn. So let's discuss a few misconceptions about math. It's a really common misconception that to be good at math, you need to be smart or have a high IQ or something like that. Let me tell you, that's a myth. All you need is hard work, and you need to do that smartly. So you can do hard work, or you can work smart for 1 day or 3 days or 4 days or maybe a week or 2 weeks. But how do you make it sustainable? An easy way to make it sustainable would be to actually enjoy while doing it. Enjoy while working hard so that you don't feel it. And while I'm explaining it to you, I'll make sure that you enjoy. I'll try my best to make sure that enjoyment is also a factor so that you can grow sustainably. So when you're learning, when you're trying to solve a problem like major fact, like how does anyone solve a hard problem, for example? You explore several ideas, and at some point you try a few ideas, 3 ideas, 4 ideas. For an easy problem, you might actually arrive at the solution at the third idea or second idea. But for hard problems, you might get frustrated. So there's this thing called frustration threshold, which is like pretty crucial. For example, I'll just give you an example with a problem or something. One sec. So just look at this problem. For example, you have 1 by x plus 1 by y equals 1 by n. N is a natural number. Now you want to find the number of integral solutions x comma y to this. A lot of you might have heard of this problem as well. So how do you do this? Like when you start off with this problem, you might like for n equals 1, you might look at a few solutions. Like for n equals 1, the answer would be only 1, I guess. X equals 2 and y equals 1. Y equals 2 as well. Half plus half is 1, and so on. Maybe for other n, there might be different solutions. So on. You might be able to solve this for small n. How do you solve it for like any n, any given n? Like some of you might just give up by looking at this question, which is okay. Like it might seem overwhelming, but then if you're like patient enough, you could do the next step. Multiply the whole thing by xy, left and right. X plus y is equal to xy by n. Bring this on this side. Nx plus ny is equal to xy. Now you might think, I mean, this didn't make the problem any easier. Like, I mean, what good did it do? Like, some of you might give up at this point. Like, so you might get frustrated. Like, I mean, isse kuch ho nahi raha hai. And that's still okay. You can increase the frustration threshold. Now you might try a few other things, like you might bring it this side, like xy minus nx minus ny equals 0. Fine. Now what do you get with this now? Like xy minus nx minus ny equals 0. Given n, what are the integral solutions to this? Still, no clue. You might give up at this point. Now, if you look at it closely, you can take x common here. You can y minus n. And if you take n common here, you get y. If you want to get y minus n, you need to add another n square on the n square, n into n. So what do you get here? X minus n into y minus n equals n square. Now finding the integral solutions to this is as good as factorizing n square. Got it? So for each factor n square, like say n is 5 or something, n is say 6 for example, x minus 6 into y minus 6 is equal to 6 square. Now for each factor of 6, like 6 square, 1 into 36, 2 into 18, 3 into 12, so on. For each factor, there is a unique solution x comma y. So for 1 comma 36, x equals 7, y equals 42, works. For 2 comma 18, x equals 8, y equals 24, and so on. So for each factor, there's a unique solution. Each factor of 6 square, there's a unique solution. Similarly, for each factor of n square, there's a unique solution for x comma y. So if the factors are a comma b, x minus n into y minus n equals n square. For each factor a comma b, there's a unique solution where a into b equals n. That's x is equal to n plus a, y is equal to n plus b. Very simple. So the number of solutions is simply the number of factors of n square, which you can like directly calculate without any costly computations. So there were 3 steps. Multiplying it by xy, and then simplifying it into factorizing the terms. So you're exploring the idea here. If you give up at any point, you won't reach the other point. So it's very important not to give up. All right. Now, what else? So, like it can also so happen that when you didn't get the problem and you're trying to look at the solution, you understand each step one step by step, but you don't get the whole picture. Like you get why the solution went from one step to another step, but you don't know why he did that. How could you have moved from one step to another step if you were in that place? Like if you were to solve the question newly, the whole picture. And I'm here to give you that. Give you the whole picture, like the essence of the problem. It's really important. And I've seen a lot of people like copying code snippets without actually understanding them. While it might be like helpful in that short term, that small period, it's really suboptimal long term. To absolutely stand out as a programmer, you need to understand each bit of your own, you need to understand each bit of your own implementation. And I'll help you with that at every step. So here's a course syllabus. Fundamentals. Start with fundamentals, binary exponentiation, Euclidean algorithm, Fibonacci numbers and recurrences, primes, and then I'll move on to take a dig at number theory. Like you can see the topics there: divisors, Euler's torsion function, modular arithmetic, and then I'll move on to combinatorics. Combinatorics is a really fun topic. It's super fun, like to think about it and solve it. You'll enjoy it. Factorials and binomial coefficients, inclusion exclusion principle. It's a pretty tricky principle. Like you know what the principle is, but it's sometimes hard to apply it at problems. Like you won't get the idea. I'll give you some examples and I'll breeze you through it. And a lot of other common problems in combinatorics which are commonly occurring. So thank you. I'll see you in my videos.